let's take a moment to develop the formula that we've been using. So I'm going to draw a set of axes. Alright, and now I'm going to draw a general function. I'll use a pink color here. And just generic something like that. This is y equals f of x. Okay, now I'm going to locate a point A on my x-axis, and then the corresponding point here. Let's label this point A, comma B. Then, like we've been doing throughout the entire course, we're going to draw a tangent line to the function. Oh, that came out good. Alright, and then I'm going to write the equation of the tangent line, which is going to be y minus y1 b equals the slope, which we can represent as f prime of a times x minus a. One of the key features being that slope. But the formula, what it does, it says, well, we consider the inverse of that function. So graphically, the inverse is a reflection over y equals x, so the inverse function is going to look something like that. And then we want to consider what is the slope of the tangent to that inverse function, not at A, but at some other point, let's say some other point B. The corresponding point to AB on the inverse function, if I go across this y equals x, that I can label this point here, and that has the ordered pair B, comma A. And what I desire is to have the key feature to the slope of that. So let's draw the tangent to that curve. So this tangent line is very important because what I want from the tangent line is the slope of this tangent line, because the slope of that tangent line will give me the derivative of the inverse at this point x equals b. Again, we desire the derivative with respect to x of the inverse function at the value x equals b. Alright, now the equation of the tangent line, not the equation of the function, but the equation of this tangent line here, can be found by just simply flipping or switching the x and the y from this formula. If you recall from an earlier class, to find the inverse, you can switch the x with the y, as I have done here. But the most important feature that I desire from this tangent line is the slope. And this form here, the way we currently see it, I don't know what the slope is. So I'm going to come down here and rewrite it so that I can put it into a form where I can identify the slope. So I'm going to start by dividing this both sides, and then I'm going to reflect it. So y minus a equals, now I divide both sides by f prime a, now I have it x minus b. And there we have it. That's in the form where I can identify the slope, and here's the slope, m. And the slope of the inverse at b is related to the slope of the regular function, but at a. And that's the formula we have been using in the last several examples. So 1 over f prime of a. Remember, it's important that f of a has to equal B. Likewise, F inverse at B has to equal A.